In case you haven't been keeping up with the last two videos in our Wormholes series, it's been made pretty clear by now wormholes are some wonky wonders of our universe. Everything about their nature just seems so crazy in contrast to the matter we interact in our everyday lives. But just when you thought wormholes were beginning to make sense, it turns out they have another surprise to them. They can function as a time machine. Imagine if you wanted to travel to the Andromeda Galaxy, which is about 2.5 million light years away. Even with our fastest rockets, we still couldn't get there within a human lifetime. Enter the wormhole. Now, if you want to go into the details of the anatomy and what the definition of a wormhole is, then I suggest checking out the previous two videos on wormholes in the Wormholes series playlist, because we're not going to be focusing on that in this video. But nonetheless, a wormhole makes our impossibly long trip to the Andromeda much shorter by enabling us to take a sort of shortcut through the space required to get to the Andromeda Galaxy. But it turns out that wormholes can be used as more than just a quick getaway. They could be the key to our past and future quite literally. How so? Well, we need to start with the basics of Einstein's theory of relativity. Let's say we have two individuals, Bob and Joe, who both have a watch on their wrist. Now, let's say Bob got onto a spaceship, which could travel at a pretty good fraction of the speed of light. Well, when Bob gets back down from the spaceship, he's going to find that his watch is ticking much slower than Joe's. That's because motion through space affects our motion through time. As you move faster through space, you move slower through time. This is a phenomenon called time dilation. It's pretty hard for us to notice the effects of time dilation on our everyday lives, but it still occurs. For example, when you're driving your car, time actually passes a few quadrillionths of a second slower for you than someone who's remaining stationary outside. Speed isn't the only thing which can affect how fast you move through time as well. Going back to earlier videos, we all know by now that gravity can also dilate time. Since the presence of matter warps space and time, the more matter present in an object, the more that object warps space and time around it, and this stronger gravitational field means time actually runs slower within that field. Gravitational time dilation is present within our everyday life. For example, your feet actually age a few femtoseconds slower than your head, since the Earth's gravitational tug on your feet is stronger than the tug on your head. Satellites that orbit Earth actually experience time at a significantly faster pace than they do on Earth's surface due to the weaker gravity at such a high orbit, and have to take this into account when providing GPS locations. These are still everyday scenarios. When we approach a gravitational field of immense strength, such as a black hole, or approach light speed, we notice that time dilation becomes more intense. In fact, if we had two individuals, and we kept one person on Earth, and placed the other in a starship which hovered safely near a black hole, or flew through space at a good fraction of the speed of light, the individual in the spaceship would notice time going significantly slower for him than back on Earth. 1 year may have passed for a passenger on the spaceship, while hundreds of years may have passed for our long-dead friend back on Earth. How could we apply this principle to wormholes? Well, it's simple, kind of. We simply put one mouth of the wormhole in a spacecraft and accelerate that spacecraft to a good fraction of light speed, and keep the other mouth in a stationary position back here on Earth. When we decide to go through the fixed mouth here on Earth and exit through the starship mouth, we'd essentially be time traveling to the past, since the starship mouth is experiencing time at a much slower rate than us back here on Earth. So essentially, it's at a different point in time than we are. Now, obviously, technology which involves near light speed travel and creating wormholes is something we haven't invented yet, and probably won't for a good amount of time. But in theory, assuming that we did, this is how it could likely work. Time travel and general relativity is something that this channel has been wanting to dive into for a long time, and with this video, that day has officially come. Now, for you hardcore physics fans, we know and are fully aware that there's more to time travel than what's in this video, but that's okay, because this video was intended as a basic intro into a whole other exotic and wacky branch of physics, and it's about time too, no pun intended. So, with that being said, be sure to stick around for the next installment in the Wormhole series, where we take a more in-depth dive into the more complicated dynamics of time travel, such as paradoxes and faster-than-light-speed travel. And as always, stay tuned for more science videos.